forward here, and then I'll let you take away.
Okay, thanks very much, Stephen. Hi guys, thanks very much for attending today, and to anybody looking at a later date, you're very welcome, and I hope this is of benefit to everyone that views this presentation. First of all, my name is, as Stephen said, is Donald Riley. I work for Heat Merchants Group. I'm the National Renewables Manager for Heat Merchants Group, and today I'm just going to run through what our offerings are in terms of heat pumps, the different types of heat pumps we have, our services that we build around those heat pumps, or sorry, so services that we provide around that heat pump in order to ensure an efficient and successful installation and performance of that heat pump. So a little bit about Heat Merchants, I suppose. We are the largest heating and plumbing supplier in Ireland. We have 31 branches nationwide in the Republic of Ireland, and we've over 300 employees. We deal not just in renewables, obviously, we are a plumbing and heating merchant, so we do a lot of over-the-counter retail. We have domestic and commercial divisions, we have partnerships with trusted global brands, and most importantly, what I want to talk about today is that we have a technical design and specification services and a service and warranty department around our renewable energy range of products. So while people might be familiar with Heat Merchants as a merchant, but when it comes to renewables, we have a very unique offering where we have a designated design team, specification team, and we also have a designated service and warranty department. And they are so important when it comes to renewables, as a lot of people that might be experienced with heat pumps may think that it's very straightforward to change your gas or oil boiler straight to a heat pump. But whether it's a new or existing house, a certain amount of design and has to be put into it, and thought, I suppose, has to be put into where that heat pump is going, and so that it's sized right, it's designed right, it's commissioned properly, and it's going to work for forevermore from that point forward in its most efficient way possible. So to start with the presentation, I suppose, to give you an idea, local branches. So wherever you are in Ireland, we're always going to have a local branch somewhere to you that's going to stock all of your plumbing and heating supplies, including our renewables. So you always have a local branch that's there to support you and to support your installer. As I previously mentioned, we have a design department that's dedicated to design department to provide Part L compliance, which is part of the building regulations now in terms of conservation of fuel and energy. We have a commission and service team, and that's all in-house. It's our own service team that's able to deal with commissioning of your heat pump upon installation, is to be able to provide service annually to that heat pump, which is very important in terms of warranty, in terms of performance. And we also offer a warranty call outs under that service and warranty. So we have our own dedicated engineers that can actually call out to remedy any situation or malfunction that you may have. So we provide it all under the one roof, which makes us as a merchant very unique. And having 31 locations, it gives us a good wide ability to have a very wide range of services to anywhere in Ireland. And most importantly, on the bottom of that display there, that screen, that slide, we have product training. So we concentrate an awful lot on product training in the renewables. That goes for consultants, engineers, assessors, and obviously installers. We're going through probably one of the biggest evolutions in heating at the moment, where we're switching away from fossil fuels to renewables, and everybody that's involved, from engineers, assessors, homeowners, and installers, including ourselves, need constant product training to keep up with the ever-changing technologies that are out there. So to give you an idea, to start off on our heat pump product range, what is a heat pump? Sorry, I just want to change something here out of my way. So what is a heat pump? So to briefly run through what is a heat pump. A heat pump, put simply, is an appliance that moves heat energy from one place to another. Air-to-water heat pumps remove heat from the air and transfer it to water. So when you look at an outdoor unit, what it's doing is it's actually drawing air in through the unit, and it's stripping that heat of all the energy that's in it in order to put it through a refrigerant cycle, which then creates heat from that, transferring it to water, and then that's used to heat your central heating system and hot water cylinder. So in the diagram or the illustration in an animation below, you see it's taking heat from the air outside through the heat pump, through the evaporator, through the coil, stripping the energy from that air, and then transferring that internally into your home. And how is it doing that? A vapor compression cycle. So a lot of people say it's very much like a fridge, and it is, but it's a lot different in ways too. It's actually in reverse. So heat pumps move heat from one place by using refrigerants. those refrigerants exist within the system as a liquid and a vapor, and it is the medium responsible for absorbing. So it's all based on refrigeration liquid. And the four main components. On your outdoor, we have what's called an evaporator. That evaporator has refrigeration liquid passing through it. And as the fans operate outside, it's pulling the air across those evaporator coils so that it's taking the energy from the heat and allowing the gas to transfer that energy through the refrigerant gas through to a compressor. And a compressor compresses that gas very much like a pump. It compresses that gas, and when you compress gas, you not only raise the pressure, but you raise the temperature. And then from that compressor, the system goes through what we call a condenser, or what you can also call a heat exchanger. And a heat exchanger allows the heated refrigerant gas to transfer its heat to the water that travels from that heat exchanger through to your hot water cylinder to heat it, or onto your heating emitters, which would be radiators or underfloor heating. Once that process is finished, that gas is now cooled down, and it goes through what we call an expansion device or expansion valve, which drops the pressure in that refrigerant liquid to turn it back into, in that refrigerant gas, turn it back into refrigerant liquid, and it goes back out to the evaporator to start the process all over again. So we have with heat pumps, you have the coefficient of performance. So why is it renewable? So when you take your example of electric radiator, it consumes a kilowatt of electricity and outputs a kilowatt of heat. With a boiler, gas or oil boiler, it consumes a kilowatt or a unit of gas or unit of oil, and it outputs 0.85 or 90% efficient of heat, or 85% efficient of heat outwards. With the heat pump, it works that way different because of the vapor compression cycle. It has an electrical energy input of, say, a kilowatt, but because the energy from the air it's taken from the air is 3 kilowatts, for every kilowatt that it actually consumes, it's producing 4, up to 5, even up to 6 kilowatts, depending on the setting, then the configuration, the type of heat pump. So it has a ratio of 4 or 5:1, which means it's generating or outputting 5 kilowatts of energy for every kilowatt of energy that it actually consumes. And therefore, that's why it's classed as renewable energy. We have two types of heat pumps. So there's two types of heat pumps on the market from every manufacturer. You have a monoblock heat pump and you have a split heat pump. So on a split heat pump, which you see in the illustration on the left-hand side, all of the components are split between the outdoor and indoor. And what's actually traveling from your outdoor unit to the indoor unit is that said refrigeration liquid as discussed in the previous slide. So as I said, the air is drawn in from the unit. It's the evaporator absorbs that energy, transfers the gas from outdoor to indoor to an internal unit where the heat transfer takes place in the condenser or in the actual water heat exchanger. So that's a split system. In a monoblock system, everything is contained in the outdoor unit. So you have an outdoor unit that consists of both the refrigerant or the vapor compression cycle, but you also have your hydraulics, which is the water heat exchanger, circulating pump, etc. It's all contained in its own unit on the outside of the building. And from there, you have your water connections, very much similar to a gas or oil boiler, where the heat is then transferred from the outdoor unit internally through your hot water cylinder or through your heat emitters, such as the radiator or underfloor heating. So we've got two types of heat pumps, split and monoblocks. When do you choose a split? When do you choose a monoblock? A monoblock system, if you're to consider a monoblock system, you'd want to be siting the outdoor unit as close as possible to the house or the building envelope of the house. That means that you're minimizing heat loss. Your heat system is running very efficiently, and you have efficient systems running as designed. When you have no choice but to put the unit away from the envelope of the house by probably more than 7 to 10 meters, that's when you should be considering a split system. Therefore, you have an outdoor unit and an indoor unit, and between the outdoor unit and indoor unit, you have refrigeration gas, and you're eliminating the possibility of heat loss and minimizing, the possibility of heat loss from the outdoor to the indoor unit, because the heat exchange takes place within the house. So you have a split and a monoblock system. Sometimes it's preference for the installer that he likes to fit monoblocks. Sometimes it's preference to fit splits. But as a service here, if you have any questions on whether you should choose a split or a monoblock, you can contact us anytime or one of our branches, and they can advise you as to what the best setup or what would most suit your house. So that's the overview of the different heat pump types that are on the market in terms of air to water. Just this illustration shows the difference. This is what they actually look like. So on our left-hand side here, we have our monoblock style heat pump. On the right-hand side, we have our split style heat pump. And in the very middle here, we have an internal unit that would go with a split heat pump or a monoblock system with a different version. In this scenario, it's for a split heat pump, but that would contain your hot water cylinder and all the components required. So it's like a mini plant room that will be placed inside your utility room or hot press. And I'll run through that in a little bit more detail in a minute. So you have a monoblock and split style heat pump. And these are the three types of configuration. So we have a split unit that ranges from 3 kilowatts all the way up to 16 kilowatts. Why would we decide a split system instead of a monoblock system? Why would we choose a 3 kilowatt or a 16 kilowatt system? That all comes down to design, one of the services that we offer. So who chooses whether it's a 3 up to 16 kilowatts? It's our installer or engineer or ourselves that would decide that. And that's done at design stage. They all have different outputs to suit different size houses and different scenarios. Monoblocks, we have from 5 kilowatts up to 16 kilowatts. Single fan units go up to 9 kilowatts. Twin fan units, which you see here on the system, go from 12 up to 16 kilowatts. And then we have another system, which is we call the all-in-one, which goes from 5 to 9 kilowatts. It's a split system. It combines an outdoor unit with an all-in-one, pre-plumbed, in its own white goods casing indoor unit. And that goes from 5 to 9 kilowatts. So that's our configuration or range of heat pumps under the Panasonic range of heat pumps, which is the main heat pump and the only heat pump that heat merchants sell from our company. A little bit of an overview on the all-in-one that I mentioned. Just it's very suitable for compact. So it's 600 millimeters by 600 millimeters. It ranges from 3 up to 9 kilowatts. And the outdoor units are very, very small. You'll see on the right-hand side, we have a 3 and a 5 kilowatt and a 7 and a 9 kilowatt. The internal unit, as I said, is 600 by 600 in diameter, or sorry, in dimensions. So it's very compact and suits same depth as a washing machine, refrigerator, fits in with your cabinets, etc., and also fits into some hot presses. Again, if the hot presses are too tight, we do have options to suit the hot press that's in question. The other version of the system, I suppose I mentioned, is a monoblock system. So we have a monoblock J generation system that comes from 5 kilowatts up to 9 kilowatts in a single fan system. And it goes from 12 kilowatts up to 16 kilowatts in a double fan system. And as I said in the previous slide, the monoblock differs is that it's got all its refrigeration and hydraulics in the outdoor unit, and you're connecting your flow and return, which is water flow and return from the outdoor unit into the internal unit. One thing that Panasonic boasts, I suppose, and have a patent on, which I want to touch on slightly today, is what we have is called a TCAP. And the TCAP, Panasonic TCAP heat pump, is what's called total capacity. And as we all know, as I described on the COP or coefficient of performance, 1 kilowatt in gets you 4, 5, or 6 kilowatts, depending on the heat pump and the setup. Our TCAP ensures that at any weather condition down to minus 25 degrees Celsius outside, that heat pump can have maximum capacity at all times. Its efficiency would be affected because of the outdoor temperature, but the actual capacity of the unit, if it's a 9 kilowatt system, it's able to produce 9 kilowatts of output down to minus 25 degrees at a water temperature up to 60 degrees. And it's able to maintain that. And that's a patented system by Panasonic that is only available through a Panasonic heat pump. And it does it very simply by, as I mentioned, the vapor compression cycle, where the heated refrigeration gas gives off its heat as it travels back to the evaporator. It passes through a dual pipe heat exchanger where it preheats the new gas coming in even further and cools down the old gas traveling out, making sure that old gas is completely turning to a liquid before it enters the evaporator again. When the refrigerant is 100% liquid going through evaporator is at its most efficient. And with the preheating of the gas going in, that dual pipe heat exchanger patented to Panasonic has the ability to supply full capacity down to minus 25 degrees, which is quite claim and which is completely backed up for a heat pump, and the only one on the market that can do so at this minute in time. So that's the TCAP technology. Heat pump cylinders, when we talk about monoblocks, so one of the luxuries we have as a merchant is that we can provide any type of cylinder for any scenario. Some retrofits have old hot presses which are very narrow. Some new houses will be fitting their systems and utilities, and some existing houses will. So we have an actual solution for a cylinder with a monoblock system to suit your style of house. All we need is the right amount of information that we will be going through in a few minutes, and we'll be able to specify and price and supply a cylinder that suits your home. And to give you an option or an idea of a type of cylinder that we have a system what we call the quick fit. It's a mini plant room inside in our white goods casing for a monoblock system that contains all of the components required to successfully install and supply a heating system for a homeowner. So for anybody that's familiar with cylinders here, you'll notice on the left-hand side view that I've shown here on the diagram, it shows everything that's inside that unit down to pressure vessels for pressurizing the hot water, motorized valves already pre-plumbed so you can provide heat and zoning the heat from upstairs to downstairs. It has a three-way valve that diverts heat from the heat pump through a cylinder and through and also the other way over to the radiators and underfloor heating, circulating pump built into it, buffer storage tanks installed, pressure gauges, filling loops, the immersions built into it. So it has everything that a plumber requires or installer requires in order to fit a system in a house that provides heating and hot water. And that combined with a monoblock outdoor unit means that you just have two items to install in a house in order to have a full heating system installed in your home. And further information that can be just got through ourselves and through our branches and myself and any of our business development managers across the country. All of our monoblocks and all of our split systems, is very important that they are all eco-designed data sheets and that they have all come with their own ERP labels. So all heat pumps on the market must meet EN 14825 in terms of central heating and what's called EN 16147 for hot water. And you'll see that on the labels here displayed in front of you, at 55 degrees, it's an A++ heating to hot water, and at 35 degrees, it's an A+++. So they are the kind of market leading ERP labels that you need to be looking for if you're considering a heat pump for your home or considering a heat pump for your retrofit project. So in heat merchants, I suppose what I try to, when we're training installers, there's 4 rules to a heat pump, a successful heat pump installation. It's not, everything doesn't depend on the quality of the heat pump. Most heat pumps, and I'll be honest in saying this, the most heat pumps that are registered or are certified EN 14825 will be very efficient and very reliable heat pumps, but it's not always the actual product that means it's a good installation or a good system. There is services around the heat pump that need to be provided in order for that to be, every heat pump installation to be a success. And those 4 rules are, number 1, the heating design. The design needs to go into preparing and sizing and calculating the size of heat pump, the heat emitters in the house. And that's a process that we do here in-house. So we have our own specification and design team. So when you're installer or yourself as a homeowner or as a consultant engineer that has a project, you can give us your plans and your information, and we provide a full heat and design. And I'll go through that in a bit of detail in 2 minutes. The second rule, installation. Installation is key, obviously. We need competent, trained installers, and that's one of the challenges we have at the moment. We've some fantastic installers all across Ireland, but there is, as I said earlier, an evolution coming in heating where a lot of plumbers are starting to have to retrain to get themselves up to speed and upskilled for the changeover from fossil fuels to renewable energies. And that's, again, a service we provide in-house, is full training to ensure that the installer installing the heat pumps is competent and trained and confident on installing the heat pump for your home. The third thing, which is very important, is commissioning of the heat pump. So commissioning of the heat pump is basically where the system is now installed, and one of our engineers calls out to set the right parameters in the heat pump to ensure that it's operating efficiently and the way it is designed for that house. And that's our commissioning is very important. And the fourth thing is servicing. So like everything in life, cars, boilers, everything, it needs to be serviced. So with heat pumps, they need to be serviced on an annual basis to ensure that it's running efficiently. It prolongs the life of the heat pump. It means it's running efficiently, and an inefficient heat pump can, when it's running inefficiently, can affect the running costs, affect the output of the system, and then it causes problems in terms of the homeowner having bills, etc. So commissioning and servicing the heat pump is just as important as the design, and it's just as important as the actual installation of the heat pump itself. So to run through heat and design, is your heat pump ready? Is your home heat pump ready? So all new homes have been built to A rated. So yeah, the new homes are going to be heat pump ready, but is your existing house heat pump ready? So as you see the little diagram here where all the energy is being consumed in the house, 37.6% of the energy in the house is for space heating, and 27.4% is for hot water. And our little diagram on the right hand side here, we show where all the heat loss in the house escapes through. So your walls, your roofs, your doors, your floors, etc. So in order to get our heat pump ready, our home heat pump ready, we need to ensure that the building fabric of the house is at the right standard or is upgraded to a certain standard. What that would mean is changing the insulation of the walls, the windows, the doors, etc. And in order to do this, or to help you do this, what we advise in terms of SAI's recommendations and part of the grants that they offer is that you hire or get a technical advisor. So a technical advisor is a BER assessor who's qualified to call out and do a full assessment on your house. He will then look at your roofs, your walls, your windows, and give you like what we call a report or a map on the best ways to upgrade your house to a certain standard. And once your house is up to a certain standard, we then, us as heat merchants, when you're considering a heat pump, we look at the home heat loss indicator, which you see on the right-hand side on the top row or top column. And we need to get your heat loss index or heat loss indicator down to a value of 2 watts per square meter of heat loss. And once we get there, then that means that your house is now heat pump ready. So in our design team and our service that we have in-house here, we look for a technical advisor's report so that we can begin to design a system that suits your house. Along with the technical advisor's report, we look for information such as architectural drawings. Okay, not everybody's going to have that. If your house is an existing house for many years, you're not going to have the luxury of having these detailed architectural drawings showing plans and elevations, etc. What we actually look for on a retrofit situation is a simple sketch. So nobody has to be Leonardo da Vinci. We can show a little sketch here that shows an outline of the house and the room sizes, the dimensions, etc. And also, if we could show the size and dimensions of the radiators, and I'll come to the radiators in a minute because they're just as important as the heat pump. So a little sketch along with your technical advisor report that comes into ourselves, into our design department, and we can then begin designing your system for you. And this is all free of charge. It comes as part of the service. The minute where your installer or your plumber gives us this information along with the advisor report, we can begin this in order for us to generate a quotation and design for yourselves. How we do that? We do a full detailed heat loss calculation. There's no back of on a paper exercise here. This is an SR50 National Standard Authority of Ireland exercise where we take the information that you've given us and we break down room by room, basing it on the glazing, the doors, the floor area, the air infiltration, etc. So we come out with a detailed fabric heat loss per room. And when we finish that SR50, it tells us the total heat load of that house. And from that total heat load, we can then specify the type of heat pump or size of heat pump that would suit that house. Along with that, we also deal with the radiators. So as a merchant, obviously we sell underfloor heating, we design underfloor heating, but we also sell radiators. So I decided today to concentrate on radiators from the retrofit perspective. So will your radiators be suitable for a heat pump? Yes, they will, and yes, they won't. It all depends, and that's where the design comes in. That's where the advisor's report come in and a bit of surveying comes in. So when you have a resisting radiator house, you're obviously running that off a gas or oil boiler at the moment. That is having a flow temperature 65, 70 degrees going through it. So that radiator has a large and suitable output based on the fact that you're running an oil boiler or a gas boiler through it. When you run a heat pump through a radiator, a steel radiator, you're running the heat pump at 45 degrees. So therefore, it's self-explanatory that the output might be that little bit less than it would be flowing at 70 degrees. However, we can check the radiators you have there. We can calculate what the output of your radiator would be should we run water from a heat pump at 45 degrees. That, along with the information that we've calculated through the SR50, we can see if that radiator is suitable, has a suitable output for the room in question. And we'll then advise whether or not that radiator has to be changed. If it does have to be changed, we can then specify as a radiator that's suitable that your installer can purchase and install on your behalf. So we do a full design, not just on the heat pump, we do it on heat emitters such as radiators, steel radiators, aluminium radiators, underfloor heating design. Questions that get asked often, can I use steel, should I use aluminium? You can use both. Aluminium is a better conductor of heat. It will heat up faster. You can run temperatures a little bit lower through it. However, aluminium does cool down faster at the same time. So there's fors and against, and nobody's right, nobody's wrong, but we offer both, and we offer design service to help you decide on what the right choice is for your home. And then the next rule, installation, I suppose, is very important. So for anybody that isn't an installer on this, I said I'd cover what is a good installer, I suppose. So a good heat pump installation, there's over 5,500 plumbers, I think, in the market at the moment, or providing their services, and they're all well skilled and qualified and done their time. But in order to make sure their heat pump competent, they need to be a qualified, competent plumber. They need to be FETAC level 6 heat pump installer. So they should have done a heat pump installer's course through a FETAC level 6 provider. So they've gotten all their qualifications in terms of heat pump design, installation, commissioning, etc. a Panasonic approved installer. So that's one thing we concentrate a lot in Heat Merchants. We travel all over the country providing training to councils, engineers, assessors, and most importantly, or just as importantly, installers. So we provide training. So anybody that comes through our doors and we train them with the Panasonic heat pump, they can be sure, and you can be sure, that they've left as a competent and certified Panasonic approved installer. SEI registered contractor. So if all of the above is done, they're a qualified competent plumber, they've achieved their level 6 heat pump installer course, and they're a Panasonic approved installer, then they will then become SEI registered in order to offer your home and your upgrade some grant support from SEI. And look, they should have some examples of previous work that they've carried out with the heat pump, and to show you that they're competent. But being honest, if they have the first 4 points covered, then they're going to be a competent installer. So installation is very, very important, and we support the installer, we support the homeowner, we support any member that's involved in a heat pump installation. We support them ourselves from the very start through to the finish. All our installers, they're provided with mechanical and electrical schematics from ourselves. So depending on what the heat pump is, we'll show them mechanical, showing the pipe sizes, how to connect to the cylinder, etc., and onto your heat emitters, valves, underfloor heating. So we find a full mechanical schematic and also a full electrical schematic, so that the plumber and the electrician both have the right size cables connecting from the outdoor unit to the indoor unit and onto your underfloor heating, etc. So we provide full support from Heat Merchants through our design service to support the installer and the electrician and any trade that's involved in the successful installation of a heat pump. Siting and positioning the outdoor unit, that's something that's quite important for homeowners and installers, is always to try and site the heat pump in a suitable place. You must have about 300 millimeters from the wall to the back of the unit, because the air is actually pulled in from the back of the unit out through the front. And from the front of the unit, you must have, it says here 1 meter, but I would actually recommend 1.5 meters. And that's to ensure that the air being passed through the unit has enough space to disperse the far side of the heat pump. Any obstructions less than a meter is going to cause that air to recirculate back through the heat pump. And you've just already, or the heat pump has just already stripped that energy from that air. So you're trying to pass the same air through it, and therefore you're going to drop the efficiency in the heat pump. So a minimum distance to the front of the heat pump of 1 meter, we'd recommend 1.5. No obstructions such as bushes and trees, etc., in the front of it, or completely covering it with a box, we'll say, for the want of a better word, or a little house. We want to not obstruct that airflow through the heat pump. Indoor units, very self-explanatory. You just need to leave 700 millimeters in the front of the unit, so the unit can be, the front cover can be taken off for servicing and warranty reasons. Siting position the outdoor unit, condensate. So as we mentioned, evaporators taking energy from air. When you have a cold surface meeting a warm surface, you will have condensation. So the evaporator will have condensate flowing from it. Not quite a lot, but it needs to have a drain beneath it, so that that condensate can be safely taken away from the heat pump, not back out onto a footpath, which would cause a slipping hazard. Commissioning, our third rule, commissioning. So in Heat Merchants, we have our own service and warranty department with our own engineers, and what we supply to our installers is the service of commissioning. So we call out and we commission your heat pump. So in Heat Merchants, we have our own customer service department. We have a dedicated service and warranty manager. His name is Stephen Cullen, and we have 4 Heat Merchants engineers. So what we provide as a service there, we provide commissioning, servicing, warranty callouts, and on top of that, we provide continuous training where your installer can attend the commissioning of your heat pump, and we can train them on site, keep them up to date on any changes and any recommendations that we see fit. The importance of commissioning, it ensures the heat pump is installed correctly. It's a full check on electrical and mechanical components, and a heat pump configured as per system design. So a lot of the time, having ourselves commission the system means that we call to commission the system. We also check that the heat pump is installed as per our design. There's a reason why we designed it. We designed it for optimum efficiency. So when we commission it, we commissioned using the controller. We set up to suit the system design. We ensure the right correct flow rates. We ensure then from that the efficiency is there. And then we use a user handover and a tutorial on the controls to show the homeowner how to operate the system. And we also provide a commissioning sheet and designer sign-off sheet to that homeowner, engineer, etc., to show that the system was commissioned properly and to show the system was designed properly. And we sign that and stand over it ourselves because we are involved in the project from start to very finish. And this is the designer sign-off sheet. So to a homeowner, you might have seen this before. Anybody that's in today as the engineer or installer, you might see a designer installer sign-off sheet. And this is a service that we provide in-house. When you come to a designer installer sign-off sheet after installation, we have a form that we actually fill out that shows the address of the home, the air code, etc. It shows all the details about the heat pump that was designed. But if you're changing radiators or if you're keeping radiators, one of the services we provide in order for you to qualify for your grant, in order to be able to sign off on this heat pump officially for your engineer, is we detail room by room on the designer sign-off sheet the type of red that's in that room and why we chose that red, the output of that red. So when we show our heat load calculations, we're also showing why we chose this type of radiator in order to achieve the correct output for that room. And we fill out that we fill out that sheet for you. It's a service we provide. It's free of charge. After installation, we ensure that any party involved in your project, we're able to supply them with the correct documentation, including the designer sign-off sheet. Servicing and warranty. Okay, so with service and warranty, importance of servicing. So like everyone, including myself, you're always not guilty of servicing the car on time, etc. Heat pumps are just as important. It ensures efficiency. So annual servicing is mandatory with all heat pumps, not just Panasonic, and that affects your warranty. But it also ensures efficient operation of the heat pump. It prevents heat pump breakdowns. It maintains the warranty in your heat pump. So if you're not maintaining your system or serving your system on a regular basis, annual basis, it does affect your warranty. And malfunction callouts covered under warranty if you're serviced every year. If something, God forbid, breaks down in between, all your callouts, parts, labor is completely covered at no cost to yourself. The warranty we provide with our system, as long as installed by a competent person, commissioned by a competent person, and serviced on a regular basis, annual basis, we provide a 7 years parts and labor warranty on all of our heat pumps. So, additional to our heat pump, we have what's called a Wi-Fi system. It's a small little Wi-Fi hub that connects to the system and provides the homeowner with a dashboard showing temperatures on the floor, upstairs, downstairs, temperature of your hot water. It breaks down your annual or your daily, weekly, monthly, yearly energy consumption in heating, cooling mode if that's required, and hot water. So it gives you a good picture of how your heat pumps are performing, that you can view yourself through the app, through our Wi-Fi hub. There's no subscription fee once you have the hub installed. That information is available to you at all times. But it also allows us to provide a service to you. So this is an example of our dashboard where we'd have many systems installed across the country where we have them connected with the Wi-Fi hub. Should there be an error, should there be a problem with the system and a phone call comes through, we can actually remotely check your system to see what the error is. If it's a malfunction of a part, we know what it is calling out. If it's a simple software malfunction or someone pressed the wrong button, it can be remotely changed without anybody needing to call to the house immediately. So it's a very good service to have in the background, the Aquaria Service Cloud. So that's our services on the 4 topics that I wanted to cover, which is design, installation, commissioning, and servicing. So for anyone attending today or watching this again, please try and remember those 4 rules, that it's not just about the brand or the quality that you think or someone tells you about the heat pump. It's the service around the heat pump that is provided to you. And that comes in the form of heating design, heating emitters design, installation, commissioning, and servicing of the heat pump ensures you will always have a successful and efficient heat pump installed in your home. So in terms of heating controls, what that goes hand in hand with heat pumps. We have various heating controls. As a merchant, we kind of have a luxury of that we have various heating controls that we can supply to any scenario. So what are heating controls? I suppose heating controls are a method of allowing the homeowner to regulate the temperature of their home through various controls, such as timers, thermostats, motorized valves, or TRVs, which is thermostatic radiator valves that you might see or have on your radiators at this current time. But modern controls need to provide time, temperature, and zone control. So most existing houses would have a time clock where they switch it on an hour in the morning and the evening. That's time control. You might have a motorized valve that's zoning upstairs or downstairs. That's zone control. Or you could have what you see on the pictures here is a thermostat, which can provide time, temperature, and zone control, which you need to achieve in every modern house and in every upgrade that you're doing. So once you have time, temperature, and zone control, you're only heating the areas you want, at the right time you want, to the right temperature you want. And to provide those, we've a wide array of them. We can provide basic analog stats, with a time clock and motorized valve to provide and achieve time, temperature, zone control. This will only achieve temperature only control to the stats. We would provide a programmable time clock. Is it my own personal preference? No, but that is available and will ensure that you achieve time, temperature, zone control. You can go a step further and get time, temperature, and zone control, which is a digital thermostat to achieve time and temperature. You combine that with motorized valves, and then you achieve your time and temperature and zone control through your heating controls in the house. And then you can go premium altogether, where you have underfloor heating, or with RADs, you can go to your Neostats by Heatmiser, which are wireless stats that communicate through what we call a wiring center that activates the appropriate zone through wireless stats that also come with their own app for you to remotely monitor as well. So we have a wide array of heating controls that we can specify for your project. You just need to, I suppose, give us that information of what your preferences are, and we can supply you with the heating controls that suits your requirements. Moving on from heating controls, I just wanted to go over a case study. So when I was thinking about case studies, I was thinking, you know, there's all sorts of different types of houses, new, existing, etc. So I decided to go for the worst case scenarios, to show people that if these people can do it, then anybody can do it if they really want to achieve. So the case study I wanted to show you was a farmhouse that is built in the early 1900s. It had an existing BER rating of G, which I don't think can get any worse without having a hole in the roof. But it's a very inefficient heating system. It had poor building fabric performance, and it had single glazed windows. And this is the before image on this slide. And to be honest, this is actually a quite generous picture, because this whole cottage was overgrown, and it was a house that needed to be completely gutted and renovated from inside to out. And it was successfully done by a person, one of our customers. And how he did that, the solution, he got an energy survey report. So what I mentioned about the technical advisor report earlier in the presentation, someone called out, did a survey in the house, recommended the different steps required to get them from where they are on the G up to where they wanted to get to, which is they wanted to try and achieve an A-rated house, which is going to be quite a feat for a house of this age. So the upgrade had to be done to the building fabric. They had to upgrade the windows and doors. They had to upgrade to underfloor heat. They upgraded to underfloor heating and radiators upstairs, and they also installed an air source heat pump. So this system needed a full deep retrofit, a full renovation. And it doesn't mean that you need to do the same thing. It's just that when I decided to do my case study, I decided to show the extreme that this person had to go to upgrade their house and get it to the standard that they required. So the solution was they built an internal timber frame structure in the house, put 85mm insulation and 65mm insulated slab. They had 80mm insulation in the rafters and 65mm insulated slab, and they had 300mm fiberglass insulation between the joists. They put in A-rated windows and an internal airtight, internal air tightness membrane to achieve maximum air tightness and insulation in the house. So now they had their building fabric upgraded to the standard so that they were now heat pump ready. So what they also installed is they put in floor insulation on the subfloor of the house. They installed underfloor heating along with aluminium radiators upstairs, which you'll see on the right-hand side image. And they put in TRVs in those radiators, and they installed heating controls, something like what I've mentioned on the previous slides. All of this solution that you see on the slide was completely supplied by heat merchants, designed, supplied, installed by a competent installer, and commissioned by ourselves. On top of that, they installed an air source heat pump. So on this property, with the upgrades that they did and the small extension, we specified them a 9 kilowatt air source heat pump, which was AAA rated, along with our all-in-one cylinder, which you'll see on the right-hand side, or you might recall from the previous slides. We put in a heat pump controller by a trained installer, and we commissioned it. That house then achieved, with their split heat pump all-in-one and an outdoor unit, is now, and you see the after results, we have an A3 rated home. They achieved their A-rated house of an A3 rated house. Excuse me, and everything was commissioned by heat merchants. And this is the finished product, an A3 rated house from the 1900s, from G up to A3, with full time temperature zone control, air source heat pump, etc. And we have an A3 rated house. To summarize what I've said, I was just literally about to finish. So summarize what I was achieved here. Heat merchant service, we provide a service around our heat pumps. We have local branches, design and specification team, a commissioning service, we have a servicing the heat pump service, and we have technical support. Our heat pump types, we supply monoblock and split type heat pumps from Panasonic. And always remember the 4 rules of heat pump installations: design, installation, commissioning, and servicing. And we support those 4 rules in-house by heat merchants ourselves. And then we've summarized on our heating controls to ensure that time, temperature, and zone control is achieved. And more information can be found for any of these products on our website, or as I said, we've 31 local branches across Ireland, so call into them at any time to ask any questions about your project, or you can contact myself through donald.riley@heatmerchants.ie, or you get my number from any of the branches, or through Stephen, I suppose, from this, as a result of this seminar. So that's me. Sorry for the little bit of an overrun on that. I hope you enjoyed it. And as I said, if you have any questions, that's no problem. So contact me anytime if any projects you have. So as I said earlier, I think Stephen's back there now. We lost you for a second. So let me finish, Stephen.
Sorry about that. That's perfect.
And we're done. So yeah, the goblins are working today on technology.
They really are. Just before you go, Donald, there was a question in the meeting was what is the lifetime of a Panasonic unit, or what's the I suppose
life expectancy.
A lot of homeowners would be thinking about is what's the life expectancy and what's also the warranty as well of the units too.
Okay, so first of all, I'll answer the warranty side, which I showed a slide on earlier on. Our warranty, as long as it's installed properly, commissioned properly, and serviced on an annual basis, is 7 years parts and labour. But we also, after the 7 years, we stay supplying or providing a service to you of servicing your heat pump on an annual basis. To answer the question about the lifespan of a heat pump, the lifespan of a heat pump is anywhere between 15 and 20 years. But to ensure that, you need to be servicing the system. And the reason I suppose, I'm not going to say I'm in the heat pump industry for 15 years, or 20 years, I'm in the industry for 14, almost 15 years. But we have customers of Panasonic in the past and other manufacturers that still have heat pumps that are working to this day, fitted over 20 years ago. And the key to it was sized properly at the time, which was rare for 20 years ago, and it's serviced on an annual basis.
That's perfect. Reiterating your point as well, the 4 kind of main steps as well. I like it. It's pretty good. It's a simple overview too.
It's so important. We often get asked the question, and it's no offense to anybody because it's a new technology. A lot of people think it is a matter of taking out the heat pump, the boiler, and then replace the heat pump. It's not, but it's not scary either. It's not it's not as big as the project that I displayed on the case study there. But there is a bit of thought to be put behind it, and those 4 steps or the 4 rules are key to it.
Excellent. Well, thank you very much, Donald, for the very insightful webinar today. As I said at the start, the webinar will be available on the YouTube link, and we might, if possible, get the slides off you, Donald, as well, and share to the participants today.
Yeah.
So
no problem.
Thank you everybody for joining us today, and special thanks again to Donald. And
thanks, guys.
You have a good day.
You too. Thanks, guys. Thanks for attending. Bye.